Good day, guys. Today in this video, we are going to be talking about the forms of projectile motion. So in our previous video, we've explained the two dimensions of a projectile body. So today we are going to be talking about the forms of projectile motion. We basically have three forms of projectile motion, which are, the first one is an object projected horizontally from a height. The second one is an object projected upward from the ground at an angle to the horizontal. And the third one is an object projected upward from a height at an angle to the horizontal. So firstly, you have to know that the case one is just talking about if you are at a particular height, then you are projecting a particular body horizontally. While case 2 is talking about the projection of an object from the ground. While case 3 is talking about the combination of case 1 and case 2. So a typical example of case 1 is that, let's say you have a ball in your hand. So the ball is placed at a particular height, then you now throw the ball. You know, as you throw the ball is going to what? Is going to move horizontally down. So the ball that was being projected at a particular height because you are throwing it with your hand at a particular height. So that is the case 1. But for the case 2, let's say you have a ball on the ground, then you kick the ball from the ground into the space and allow the ball to move in an horizontal direction. That is for what? For the case 2. But if I combine the case 1 and case 2 together, I'm going to guess what? Case 3. So for my case 1, this is when an object is projected horizontally from the height. So this is the height. This is the height, guys. This is the height of projection. While this is the object that is being projected horizontally downward. So the height h is this, while the distance covered by the object is called the what? Range, or the horizontal distance. So for this case 1, you have to know this formula that T is equal to square root 2h over g. Height is h, acceleration to gravity is g. While our r, which is the horizontal distance covered, is the what? Is equal to ut, and is equal to what? U square root 2h over g. So let's talk about that, guys. So let's look at a particular example in order to use this formula. So guys, in this example, the question is, a ball is thrown horizontally from a height. Since the ball is thrown horizontally from a height, this is talking about the what? About the case 1 of projection, of projectile motion. This simply means that what we have to, the formula we should have in mind should be T is equals to square root 2h over g, while the second one is R is equals to ut. So let's continue. A ball is thrown horizontally from a height of 30 meters. This simply means that, guys, my solution, then the height h is 30 meters, right? With an initial speed of 20 meters per second, then our u is equals to 20 meters per second. Calculate the horizontal distance traveled. Guys, what do you mean by the horizontal distance traveled? That is the r. We are looking for the r. R is the horizontal distance traveled. So by the ball, when it hits the ground, so g is equals to 10 meters per second. Our g equals to 10 meters per second. Since we are looking for r, you will just remember the formula for r to be u square root 2h over g. This is the formula for the horizontal distance. This r represents the horizontal distance travel. Another name for the horizontal distance travel is the what? Is the range. So therefore, this can then be equal to our u is 20 times square root 2 times 30 all over 10. Then this should give us 48.99 meters if you do it correctly, guys. So let's look at case 2, guys. So guys, let's talk about case 2. So case 2 is talking about an object projected upward from the ground. So for example, let's say this is the point of projection. So this object was projected upward. Let me extend. Let's say this object was projected upward. Then come back here. We can draw the horizontal direction to be this. This is the x. This is the y. So guys, let's do this together. We know that this object was projected upward as if you have a ball on the floor, then you kick the ball upward. So the way that this object was projected upward, then this object reaches a maximum point. This point is known as the maximum point. Maximum point. So as it reaches the maximum point, then it comes back. to the what? To the projection plane. So guys, the distance this object, it took this object from this point to this point, is what we refer to as the horizontal distance. And this horizontal distance is called the range. Can you differentiate between the maximum point, or let me say the maximum height, rather, the maximum height? So can you differentiate between the maximum height and the horizontal distance now? Another name for the horizontal distance is what? Is the range. So horizontal distance is just talking about the from the beginning to the end. Do you get that? So guys, you also have to be very careful. You know that when this object starts from rest, it firstly reaches the maximum point, the maximum height, before it comes down to the projection plane, right? Guys, you have to know something, that it requires a particular time to move from this point to this point. The time it requires the object to reach the maximum height is what we refer to as the time taken to reach maximum height. And that time taken to reach maximum height is usually denoted by this small t. So guys, from the knowledge of kinematics in one dimension, when we are talking about an object projected upward, you have to know that the time taken for an object to reach the maximum height will also be the same time for the object to move from that maximum height back to the projection plane. If it takes this object 2 seconds to move from this point to this point, then it must also take this object another 2 seconds to move from this point to this point. So that is why the time taken by the object to move from the initial point to the maximum point will be the same time it will take the object to move from the maximum point back to the initial point. So if year to year is t, year to year will also be t. Year to year will also be t. So therefore, guys, you have to be able to differentiate between two things. We have the time taken to reach the maximum height, and we also have what we refer to as the time of flight. Guys, the time of flight simply means the total time taken by the object, or it simply means the total time taken by the object in air. If you're talking about the time of flight, it's talking about the time it takes the object to move from the initial point to the final point. So, time of flight can also be referred to as total time of flight, or total time spent in the air. So the total time spent in the air will be the addition of this and this. So guys, let's talk about the formula for the horizontal distance, the maximum height, the time of flight, and the total time of flight. Whenever you see this small t, is talking about the time taken to reach the maximum height. But whenever you see this capital T, is talking about the total time of flight. That is to say, the addition of the time taken to reach the maximum height with the time it will take from that maximum height back to the initial point. So the formula for this small t is u sin theta over g, while the formula for this capital T is 2t. That is to say, it is this t plus t will give us what? This capital T. So the total time of flight taken, or the total time spent in air, will be equals to 2 times small t. And that's why the formula for this capital T will be what? 2u sin theta over g. We all have the height. The formula for height is u square sin square theta over 2g, while the formula for range is what? U square sin 2 theta over g. These formulas, you must know them, and you must not confuse them with each other. So you don't have to know another thing. What you have to note is that the height maximum height of a projectile motion will be maximum when the angle is what? 90 degrees. While the range would be maximum what? At 45. You must not forget. So let's look at a particular example. A ball is thrown up with a speed of 10 meters per second at an angle of 50 degrees. The angle is 50 degrees. This simply means that theta is equal to what? 50 degrees with the speed u is equals to 10 meters per second to the horizontal. So guys, before I continue with what I'm doing, guys, whenever you have a physics question, physics is very simple, but you take note of some important want to approach the question. The question says 50 degrees to the horizontal. You have to note from right now that the angle of projection must always be to the horizontal. If they want to confuse you, particular question, the vertical. If you are doing a projected motion and the angle is to the vertical, before you write down the angle, you must convert that angle back to the horizontal. And whenever a particular angle is to the vertical, you want to convert back to the horizontal, just minus the angle from 90. Then you are going to get your angle to the what? Horizontal. But because this question, the angle is already to the horizontal, so I don't need to convert it again because my angle must always be to the horizontal. I will need to convert if the angle is to the vertical. So write down the parameters. The question is that calculate the height to which the ball rises. We are looking for the height. Calculate the time taken to reach the maximum height. Guys, time taken to reach the maximum height is talking about this T. What the question is time of flight. Time of flight is talking about the total times air. It's talking about distance. It's talking about what? Range. Don't forget. The horizontal distance is talking about what? About range. Now let's do this. So guys, for height, number one. So if you are looking for the height, equals u squared sine squared theta over g over 2g, and that's equals to our u is 10 squared. Theta is 50 degree over 2 times 10, and the final answer will be what? 2.93 meters. If you calculate this very well. The last taken to reach the maximum height, small t, to u sine is 10 sine 50 over 0.76. And for that, the unit for that is second. And guys, if you want to calculate the time of flight, that is capital T. That would be 2t. 0.76. You're going to get 1.53 seconds. So guys, you have to be very smart. Direct. They might not say it's the time of calculate the time. So in that case, time of flight directly. Formula, just to take this formula. But the formula is because so I can just multiply to get my time of flight. How you are going to be approaching the horizontal distance. So for our R is equal to over G 10 square 2 10. Then the 5 same units. So thank you very much for watching.